All right, this is kind of the part two. I just wanted to show you a few other things. I'm going to zip through the general how to do the example just so I can get to the end. But example 2 of this lesson 1.4 regression is asking a different type of question. It doesn't just say what's the model. So part A says find the model or write an equation for the data up above for crickets chirping versus time or temperature. So part B, though, we can do part A. We just did that in example 1. But part B says using the model, what would you predict the temperature to be if you're finding the crickets chirping 13 times? So based on the number of chirps up here by a cricket, we don't. First of all, we don't have 13, so we don't have an exact correlation. But even that, what we're trying to do is estimate it anyways. So part B, we're going to find the equation. Part C, we'll go back and says, using your model, you know the temperature is 50 degrees, then what is the estimated number of cricket chirps? So first thing I'm going to do is show you generally how we can clear everything out. So let me, cleared my key history. So what you can do is you just make sure to clear your equation out. And then one thing you'll also want to do is go back to stat, the stat button, and then go back to edit. And we want to edit our L1 and L2. So if you want, you can just write right over these data points. The problem is if your new set of data has less inputs, we need to shorten this up. And I can show you that in a minute. But the easiest way to clear an entire list is to go up to the label L1 and then hit clear, enter. And it clears the whole thing. If, let's say, you make a mistake, whoops, I accidentally typed in 10,000, I meant 9,000. You can't just hit clear and enter. It'll just keep showing it up, right? It's just gonna keep it. So if you want to actually delete a cell, if you will, what you have to do is go to the cell you want. So in this case, the 10,000. Instead of clear, come up here to the delete key, hit delete, and it's gone. So you can do that too. You can go out and delete everything. Delete, delete. I'm going to go back to the top, hit clear, enter, and the whole thing is gone. So I'm going to pause for a second because what we need to do now is actually go ahead and enter our data for example 2. So there's no reason to have the video going for that. All right. While I was pausing, I went ahead and went into the calculator. If you look, we've got L1, L2 entered with all of our data of the number of chirps and the temperature. Excuse me. So we need to find a model that represents it. So the first thing I'm going to do is go right to, I can go to graph. It still has the old plot. And the reason for that is because our window hasn't changed, so we don't see anything. I'm going to zoom 9. Zoom 9 gives me all of my data. At this point, we're trying to guess what type of an equation. Is it a straight line? Is it parabola? Logarithmic? So I'm just going to say it is linear. I know it's not a great representation, but I don't see any trending up or down or over. I just see this fairly straight line. So with that, I'm going to go to stat, over to calc, and I'm going to say that this is a linear regression, mx plus b. They call it ax plus b. So our L1, L2 represent our data. We want to know the equation, and there it is. Now, if you notice, our R value, that's the correlation coefficient. That should be as close to 1 as we can. It's a 0.83. You could try other regressions, quadratics, cubics, and things, but I don't think it's going to get any better. So we're going to use that as our equation. So we go y equals, and in our y1, we need to type variables, go down to 5 statistics, and then we go over to the equation that we want to put in y1. Happens to be number 1, we hit enter. So there's our equation, and if we graph it, that's what it looks like. Good, not great, but it's the best we can do. So we can now actually look at our information. So part A says, yes, find a model. So you would take those values of A and B and write y equals ax plus b with those coefficients put in. Part B, using the model, predict the temperature if you recorded cricket chirps 13 times. So our chirps happen to be our x values. So it's asking us, hey, let's trace this thing. Well, if I trace it right now, I don't have any, I'm actually tracing on these data points. See where my cursor keeps moving to data points? Well, we want to use our regression equation to find that number. So how do I get to trace this number, or this line here? It's very simple. Right now, if you look at the top, it's telling you I'm tracing plot 1. If I go and hit the up arrow, or down, it doesn't matter. If you keep hitting up and down, it'll switch. The up and the down switches you between two different things that you plotted on your screen. So if I went to the up arrow, I see that I'm now tracing my y1 equation. So my y1 equation, if I hit arrow over, you can see that I'm actually tracing the equation line. So we want to know when x is 13, which is 13 chirps. So I can type, while I'm in the trace mode, I can type 13 and hit enter. And look at that. We can't. Why is that? Well, if we go to your window, nope, sorry, I got to clear out of that. If I go to my window, I notice that my x minimum is only 13.84. So my window currently doesn't go that far. So it's saying, hey, I can't trace down to x is 13 because your window doesn't allow me. So I'm going to change that while we're in here. Let's change our x minimum to 12. If I graph, I do want to make sure we should be okay. If I hit trace, we're back to plot. So I got to go up or down arrow. I will go to 13 now. There. Okay, so now that I trace 13, it says the temperature would be, according to our estimates, temperature would be about 68 degrees. So to answer B, using your model, we typed in x is 13, and we would say we predict the temperature would be 68 degrees if we wanted to find 13 chirps in a second. Okay. You do something similar in part C. It says, now go the other way. Fit y equals 50 into the equation and solve for x. You can do it algebraically. You can go back to your calculator and trace. I believe there's a way to do that. If you go second trace, so you're calculating value. If you hit enter, that's not going to work. Never mind. So I was going to say by 50, but it's going to get mad at us because it's still tracing your x. So if I just graph that and trace, that might be one way to do it. I would also consider doing this algebraically. Just simply go back to part A, the equation that you wrote in part A, and put 50 equals ax plus b, solve for x. Since I haven't done that, I'm going to see if maybe this might work. I'm going to trace the equation. So we know at 14, we're at 70 degrees, so 13 is 68. So what we're finding is our graph, I'm going to go clear down to 12, it's going to max it out. We're only at 64 degrees. So the question is, if the temperature is 50, what would you expect the number of chirps to be? Well, I need to change my window because currently my window is maxing out the bottom corner at 64 degrees. So I'm going to pause this and find a good window. Okay, I actually found the window. I decided to just make our x value 0, since we know the x, if we go to 0, it's fine. The problem was down here, y max and y min is set at 45 because we know that we want to go no less than 50 degrees. So I changed x min to 0, y min 45 degrees. And you can see our graph shows pretty much all the information we need. I'm going to trace. If I have the up arrow, if I go down to like 5 chirps, that's 41 degrees. If I go to 10 chirps, target for the problem is 50. So if 7 is too low, 7 chirps too low, if we go to place 8, that's 51. So 7 is too low of a temperature, but if we go to 8 chirps per second, it is too high. So what I would say is, using the model, if you know the temperature is 50, what would you estimate the number? I would answer, my estimate would be between 7 and 8 cricket chirps per second. So the rest of these are similar. You have different data, and the questions at hand ask you to interpolate or extrapolate the information. So good luck, and we'll see you in class.